Welcome to the project demonstration of sizing and analysis of renewable energy source and battery systems in residential microgrids. So in the project, we are using solar panel as a renewable energy source and also battery. So coming to the solar panel ratings, 12 volts 5 watts and battery is 12 volts 2 amps. So this battery pack consists of two 12 volts 1 amp batteries are connected in parallel, and each battery pack has of 3 4 volt 1 amp batteries are connected in series. So these three are in series and these two sets are in parallel. So we will get 12 volts 2 amps, and the voltage generated from the solar panel as well as the stored voltage in the battery continuously monitored by the microcontroller. So as this is called as of a sizing and analysis for the renewable energy sources as well as battery management system. Battery system monitoring, and based on this we are going to utilize the source voltage which is stored in the battery to the home appliances, so using the microgrid application. So this all from here, this system is called as a microgrid. So that's why we are making use of one inverter. So in order to convert the DC to AC, so we are making use of this inverter. So this inverter consists of RLC circuits. So on this one there is a one capacitor, resistor along with the inductor. So in the combination of these three components we are going to generate the pulses with a 50 hertz. So that is called as an oscillator. Without giving any signal, it will generate the required frequency signal. So that is signal given to the two MOSFET gates, so that we will get the, here we are getting only 12 volts AC signal, and that will be converted into 12 volts 2 amp signal with the help of these two MOSFETs, as these are in between the transformer and the battery. So the same switching frequency given to the gates here and the same voltage with current given to the transformer, as it will convert to DC to 12 volts AC, and the transformer will convert the 12 volts AC to 230 volts AC signal, and that was given to the our home appliances. Like for demonstration purpose we are making use of this 20 watts AC bulb. So here we also have the one more source of charger, that is a transformer. So from this transformer, by providing 230 volts AC input, so which will step down the 230 volts AC to 12 volts of AC, and that is input to this charging circuit. So this charging circuit for the battery and the transformer, this charging circuit is for the solar panel and the battery. So on both charging circuits we can see the 4 diodes which are placed for the convert to AC to DC. So here we are providing AC from the transformer, AC 12 volts AC, and there these 4 diodes will act as a bridge rectifier to convert the AC to DC. But on this one, so we are providing DC to the charging circuits, but these 4 diodes will act as polarity corrector, not the AC to DC. So polarity corrector means if you connect the DC input in reverse polarity, they were place to place instead of place to place. So if you connect the plus to minus, minus to plus, then if we provide that as it is to the battery, then the circuit may get damaged, either battery or a solar panel. So in order to protect that, we are using these 4 diodes to convert the reverse polarity to the same polarity. So as we know that bridge rectifier will provide us plus to plus, minus to minus in the output side, whether if you provide the input in reverse polarity also. So that's why it will convert the reverse polarity to correct polarity. Here we are using this as a polarity corrector, and after this output same through these 2 diodes on the same charging circuits. So by using this through these 2 diodes we are sending that 12 volts there from the bridge rectifier or here from the solar panel given to the battery parallelly. So now whenever the battery is fully charged, so if the sunlight is not available, so if it is fully charged one, so these diodes will block the current from the battery to the sources. So in order to protect the charging circuit and sources, we are making use of these 2 diodes here, and there is a light indication on this charging circuit to show the availability of the power. So let us see, when we if you want to charge a battery by providing 230 volts AC input as from the grid, so just on the power supply to the transformer, then there is a light indication on this one. When we place this solar panel under the sunlight, so then this light will be on, and a generator voltage continuously monitored with the help of the 2 voltage sensors. This one is for the solar voltage measuring purpose, and this one is the battery voltage measuring purpose. On these two we can see 2 resistors. these two are the, one is the 10 kilo ohm, another is a 1 kilo ohm. So we are going to divide the input voltage into 10:1 so that the microcontroller can measure up to 50 volts. So because controller can measure maximum 5 volts, when we are providing the higher than the 5 volts, then we need to divide that into the ratio based. So in our project, we are using the ratio of 10:1. So microcontroller will measure that. So these two voltage sensors given as input to the A0, A1 pins, and the so-called status of these two voltage availability displayed on the LCD screen directly, which is connected pin number B2 to B7. So here we are using the main controller number is PIC16F72. So when we are providing 12 volts AC, 12 volts DC input to the motherboard, so then we are using one 7805 regulator as it required only 5 volts. So the 7805 regulator will take 12 volts DC input and provide us the 5 volts output DC. So this is the main on-off switch to measure the voltages right now. So let us see the demonstration. So when we switch on this, and there is one more switch. So this switch is used to on the load. So directly we are going to convert the DC to AC as the flow from 12 volts DC to the RLC circuit to provide the 12 volts AC, and that will be converted into 12 volts AC with 2 amps currents, and that will step up to the 230 volts AC with the help of this transformer. Okay, this is the main on-off switch for the load purposes, grid application. And the next one more on-off switch to measure this sizing of this two voltages. So as we are demonstrating this under the roof, so we are getting less voltage. So when we place the lighting on this solar panel, flash it on. So we can see that the voltage got increased. Right. Okay, so the battery is now fully charged as it's showing the 13.5 volts. So generally if you want to charge a battery, so you should place the solar panel or transformer. So we should keep on the charger at least for 8 hours. Then the battery will be fully charged. So if you want to charge a battery from the transformer, then you should on that for 8 hours and you can off the circuit. So now the battery is charging from the transformer. So if you want to charge it from the solar panel, keep this under the sunlight and leave that, so it will be fully charged in the duration of 8 hours. So as you can see that when we place the flashlight on the solar panel, then there is a light indication over here. Right, you can see that.